Okay, in the recap, question 1, I just want you to tell me what you would use to solve this. Okay, so a permutation is when you're doing an order of something. A combination is just you're grouping. Factorial, that's when you're kind of lining things up or just counting. Accounting would be like on a lock code, right? 10 times 10 times 10 or something like that. That's just counting because you can't permutate that. Okay, so selecting a sports team. So you need 5 people on your team and you have 15 people to choose from. Which method would I use? Combination. Okay, I just need to make a group. Okay, I have 10 people. Let's say that they did a race, and I'm going to give awards to gold, silver, and bronze. How many ways could that happen with 10 people in the race? Which option would I do here? That would be a permutation. Because I'm ordering, I'm changing the order. I could give somebody bronze and then this person gold, or switch. The order matters. If you're trying to put 10 people in a line, you're lining them up. That would be a factorial. And picking out an outfit, if you have to pick 1 pair of shoes, 1 pants, 12 shirts, you could consider that counting or combination. Because technically you could do 6, choose 1. 10, choose 1. 12, choose 1. Or 6 times 10 times 12. Because that's the same thing. Okay, how many different outfits are possible if you have to have shoes, pants, top? Okay, I have 6 shoes to pick from in my closet. So I'm going to do 6 choose, I need to choose 1 shoe to wear. There's 10 pair of pants in my closet, and I need to pick 1 pair of pants. So that's a 10 times 1. I have 10 pants. I need to pick 1. And there's 12 shirts in my closet, and I will have to choose a shirt. What should I do with these? Times them together or add them together? Multiply, because you're doing all of those things at the same time. It's not an either or. So this is a 6, by the way. When you choose 1, it is just that number itself. Okay, the next one, you have 11 players on your ball team. How many different ways could you put players in the game? How many players are in a baseball game, by the way? You should probably just know that, hopefully.
Why would we know that?
Because I'm hoping you have life common knowledge on this test. Come on, you guys.
8. No?
9.
Don't you play baseball?
9 people are on a ball team.
Why didn't you say that earlier?
Okay, so there's 11 people, and I have to choose 9 people to put into the game.
It's just like, over every.
All right. See if you can get your buttons going there. What's that? I don't know if I put anything like that on a test, but if I did, I probably would say, tell you. Okay, this time I have those 11 players again. How many different batting lineups can I make? So a batting lineup is when you say, hey, Danate's going to be my leadoff hitter. Okay? All of a sudden, right? I'm putting people in the lineup in a certain position. So what am I going to do different in this question? I'm going to permutate. Okay? Because now the order matters of who I'm putting in the lineup first, second, third, fourth. Okay, same question, still have 11 people on my ball team and I'm trying to make a lineup. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm trying to make my lineup with 9 people. This time I already know that I want Jake in my first spot. My number 1 hitter is Jake. So there's only one person to put in that blank. I already know I want John in my number 2. So there's only one option in the second spot. Jerry is in the 3rd and Josh is in the 4th. So those only have one option and then the rest doesn't matter. So how many options do I have to put somebody in my 5th position here? 7 players remaining, then 6, 5, 4, and 3 options. Okay, so something like that, or I could say, on your test, you might see something similar to that question, like you need somebody to be on the ends, or ends and middle, or whatever, right? Okay, factorials. You're going to have one of each of these questions on your test, one with numbers, one with letters. Okay, when you're doing this, what are you looking for? The largest one, and you start going down. So which one is larger? 11. So 11, then comes 10, then comes 9, and beyond. I stopped there because I always want to go till I meet another factorial. So these would cross off. And what happens in math when something gets crossed off? Is it the value 0 or the value 1? When something gets crossed off, what does it make? 1 over 110. Okay. By the way, if you used your calculator and you just did that and gave me that answer, I'm going to award you 0 points. So don't do that. You have to show me your expansion stuff, okay? Okay, next one, I have an n plus 3 factorial and an n factorial. So which one is larger? You expand the larger one. N plus 3. Okay, we need to go down. So the next down is n plus 2. N plus 1. What's the next in the order? Just an n? I'm going to stop there. So I expanded all the way to an n factorial as soon as you get to another one. This crosses off. The n plus 3 also crosses off. What will you do in math when you have something that looks like that beside each other? What do you have to do in this case? How do you times those together? What's the system? FOIL. So first, outside, inside, last. See if you can FOIL that through. Multiply the first, the outsides, insides, and last. That's as pre-calcy as we're going to get in this unit. Okay, making codes. I actually have quite a bit of these styled questions on your test. Okay, for password code here. So 1, 2, 3, 4. I'm just going to do that. Okay, I have the digits 0 to 9. So that is going to be 10 options. And the letters, how many letters is that? A, B, C, D, E. So there's 5 letters I have. Okay, how many codes are possible if it is made up of 4 digits and there's no restrictions, so I can repeat? So digits, they all have to be digits, so this would be 10 options of digits. I have another 10, 10, and 10. Okay. A code is made up of 4 digits, again, but you can't repeat. So they all have to be digits. So the first blank, I would have 10 choices. And then now I only have 9 options, 8 and 7. Okay, I must contain 1 digit. So if it's got 1 digit, it will have 3 letters, right? If it's going to only have 1 digit, it will also have 3 letters in it. So 1 digit, I'm assuming this time I can repeat again. 1 digit and 3 letters. But there's something else. I could have, this is my passcode. I could go digit, letter, 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 or I could go letter, digit, letter, letter, right? Or I could do letter, letter, digit, letter. So there's 4, and I have to choose one space to put that digit in. So there's 4. Do you see? I'd listed them. There's 4 different ways you could do that. Digit, letter, 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 digit, letter, letter, right? There's 4 ways you could do it. So I have to times that by 4 yet. Okay, you must alternate between letters and numbers. So there's actually 2 scenarios here. Scenario 1, would it go digit, letter, or what else could I do? I could go letter, digit, digit. Because it just says to alternate, but I don't know which one I need to start with. So I could have this or that. No repeats. Okay, so digits, there would be 10 on that and then 9 on that. The letters, I have 5 letters and then 4 letters to pick from. Okay, and this one should be the same, right? 5 and then 4. And this should be a 10 and then a 9. Okay, so when you figure this number out, you're going to have to add or just times by 2, right? Because it's this and this are the same. Okay, you're going to line up some cups, and the cups are identical to each other minus the color. So when I have 3 blue cups, those 3 blue cups are the exact same. Okay, so you can't tell them apart. So if I have this blue and then I switch them, you can't even tell that I switched them, right? Because it'll look the same. So how many arrangements do I have? So 3 plus 7 plus 2 makes 12 cups. So I could move around 12 cups. But what do we know, as in the example I gave you with Dad, right? If I switch the D's, I have to cancel. So 3 factorial, I cancel the blue cups being identical, the red cups get, and the yellow cups. So this was also the same as when we were spelling words with 2 of the same letter. You have to cancel the repeated. Okay, because it's not going to matter if I switch something, it's going to look the exact same. Can you see if you can type that properly? Because that will need to be in brackets. Okay, So when I did it, I pushed divide by, and then I did that all in brackets. Okay, I'm going to skip the next question. I don't really like the wording of it. Okay, you have 2 adults and 3 children, and you're trying to do a family photo. How many arrangements are possible if? So I'm just going to draw these 5 blanks here. The adults have to be beside each other and the children have to be beside each other. So I'm going to circle like that. The adults, they're a group. The children are a group. So how many groups am I moving around? 2. I could either be doing adults, children, or children's adults. Then, so that's the groups. What happens within the group? So what could the adults do? They could do 2 factorial. And then the 3 children could also move around. Okay, the next. They're going to alternate, and they start with a child. So it's going to go child, adult, child, adult, child. So I'm going to go through just the children. So this is 3, 2, 1. Those are the options for putting the children in those positions. And then the adults, this adult would be a 2 choice. And then on this position, I only have 1 left. Okay, this time I'm grouping just the adults together. So the children can get separated. So I could go adult and then child, child, child. I could go child, adults, child, child, right? I could move them around like that. So how many groups am I moving right now? How many groups are there? Not 3, not 1. There are 4 groups. The adults are 1 group. Each child is its own group. So 1, 2, 3, 4. There's 4 things I'm moving around. But what can the adults do within their group? I'm going to do one more question on that. Okay, what if the adults don't want to sit beside each other? The adults are not going to sit beside each other. Okay, what am I going to do in this? I'm going to do, remember the strategy? All minus opposite event. Okay, if I just have, forget for a second, adults and children, how many ways could I just put all of those people in positions? 5 factorial. With no restrictions, I don't care if they're an adult or a child specifically, I could just move anybody anywhere. So, If the adults don't want to sit beside each other, the opposite event is if they sit beside each other, which is what we just did. If they sit beside each other, we just did that. All minus if they sit beside each other will give us the options of them not sitting beside each other. Okay, so there are some questions on your test where I suggest you use the all minus opposite strategy. Okay, how many ways can you travel? Apparently I made this very tiny. Okay, I need you to go 1, 1, 1, 1, 1, 1, 1, all the way across the top, all the way down. Only one way to go all the way east or all the way down. Okay, you can now start your adding. Okay, so I'm going to stop and pause here. I just went to a 15 and to 35. I'm sorry, this is so tiny. Is anybody getting those numbers? 15, 35?
Yes.
Okay. Okay, when you get to this position, you're actually going to now have to slide the 15 over because there's no extra paths to go straight over. And also the 35, you're going to slide it straight down because you're not going to be able to deviate from that. Okay, and then you can finish your adding. Anybody with a 270 if they got to the end yet?
270, are you sure?
Oh, well, now you're making me question what did I do here? You got 150 and no one's getting mine? Maybe I
got it.
You got 150? 270? 270? Okay. This is an 85. Okay. Remind me later when I go done this. I gotta go edit that. I gotta definitely make that one bigger. Okay, forming a committee. You're trying to make a committee of 4 people. You have 8 boys, 11 girls, and you need a committee of 4. So if there is no restrictions, I can choose a committee of 4 from how many picks do I have? How many choices? 19. I could just pick anybody. So this would be 19 people. Okay, picking a committee, no restrictions. You need exactly 2 girls and 2 boys. So I'm going to do 11 girls to choose 2 from. And so I'm timesing. I have 8 boys, and I'm going to choose 2 of them. Okay, the next one says at least. So there's going to be multiple scenarios. We need to learn at least. At least 2 boys. So I could put 2 boys on there. I could put 3 boys. Or I could put 4 boys on there. Those are the different scenarios I have. Okay, some of you might think, well, sometimes don't I do the opposite event? Okay, you could, but it's actually not really any less work because the opposite would either be no boys or 1 boy, which now you're doing 3 things as well. So may as well do this because the opposite event isn't any less work. Okay, so if there's 2 boys, there would be 2 girls. We actually just did that one above, right? And we got 1540. We just did that question with 2 boys and 2 girls. Or, so I'm going to add the different option. Okay, if you put 3 boys on there, that's 8, choose the 3 boys. But I would also need to put 1 girl on that committee. Or, so another add. If there's going to be 4 boys, I'm going to go 8, choose 4. Okay, and then I'm not putting any girls on this committee. So you don't have to write anything. If you wrote 11, choose 0, that's fine, but it's just 1, so it's not changing anything. So I don't need that. If you have it, that's fine. Okay, you're going to have one of those questions basically on your test, the same thing, where I have a committee, no restrictions, a committee with exactly this, a committee with at least this. Okay, this time our committee has to just be 1 gender. So it's a multiple case scenario again. What are our options to have 1 gender? We could have a committee with all girls. That's one option. Or we could have all boys on our committee. So if we did an all-girl committee, we're going to choose 4 girls from 11 options. Or with the boys, we're going to choose the 4 boys from 8 options. Okay, and then do you see why I'm adding them? Because my committee has either all girls or all boys. That's two separate ideas, not together with each other. Okay, the last question. I have a bunch of novels. So how many is that for my novels? 5, 9, 12. I have 12 novels. And I'm putting them on a bookshelf. It says when I put them on my bookshelf, I have to have them grouped according to their category. So the romance novels all have to be beside each other. Same with the fiction. They all have to stick together because they have to be grouped. Which method do I use here? How many groups are you moving, and then what's happening within the groups? It's that strategy. So I'm moving 3 groups around because I could do romance, fiction, thrillers, or I could go fiction, thrillers, romance, right? I can move them around like that. Then I could move the romance novels around. I could move the fiction novels around and the thriller novels around. Okay? So we've seen that concept a few times.